Good afternoon, dear students. How are you all? This is Irshad. I can help you to understand the numericals of calorimetry. In the last class, we have done five numericals from calorimetry 11b. In this session, we are going to solve from 6 to 10. I mean, five more numericals we will solve in this session. Let's start the first. In an experiment, 17 gram of ice is used to bring down the temperature of 40 gram of water at 34 degrees Celsius to its freezing temperature. The specific heat capacity of water is 4.2 joule by gram Kelvin. Calculate the specific latent heat of ice. State one important assumption made in the above calculation. What is given in the question first? He said the mass of ice is 17 grams. It is in the ice state, solid state. 40 gram of water at 34 degrees Celsius. The final, the final temperature at freezing point, at 0 degrees Celsius. The specific heat capacity of water is 4.2 joule by gram Kelvin. What we need to find out? We have to find the latent heat and one assumption. Then let us consider this is the mass of the ice is capital M, mass of water is small m. Then I will write the equation here. According to method of mixture, amount of heat energy gained by cold body equal to amount of heat energy lost by hot body. I mean net gain equal to net lost. So according to that, the cold water, the cold ice at 17 grams, ice 17 gram of ice gain the heat energy to change its temperature, and 40 gram of water is changes its temperature. We have an equation to find it is ml equal to emc delta t, where capital M is the mass of the ice, small m is the mass of the hot water, T is a specific heat capacity, L is the latent heat, and delta T is a change of. What is the change of temperature here? The initial temperature is T1, the final temperature is T2. Initial is 34 degrees Celsius, and he said the freezing temperature. The final temperature is 0 degrees Celsius. Then we will find that change of temperature is what you will get 34 degrees Celsius. 34 degrees Celsius. Yeah, I will take the values into the equation to find the L value. This is 17 into L. Mass of the body, mass of water is 40. Specific heat is 4.2. Change of temperature is 34. We'll use 17 table. 17 1 ja, 17 2 ja. Finally, I have a equation here. 42 ja 80 into 4.2. Please try to multiply 8 into 42. Then L equal to 8 into 42. Multiply it. 336. This is 336 joule by gram. Have you understood? Good. We'll go for the next one. The temperature of 150 gram of water at 50 degrees Celsius lowered to 5 degrees Celsius by adding certain amount of ice to it. Find the mass of ice added. Given specific heat capacity of water equal to 4200 joule by kg degrees Celsius and a specific latent heat of ice equal to 3 lakhs 36,000. We don't know what is the mass here, but we are adding. We don't know what is the mass of ice, but we adding here. So the ice is in the solid state. The ice at 0 degrees Celsius. The solid state at 0 degrees Celsius. Then who is the gaining the heat energy? Who is the losing? According to method of mixture, the cold body is getting the heat energy, and hot body is losing the heat energy. So here the mass is given here 150. Let us consider this is the small m, the mass of the water, and it is initial temperature is 3 degrees Celsius, and the final temperature is uh, 5 degrees Celsius. From this method of mixture, we will write it here. First, the amount of heat energy gained by cold water, or I mean ice. I will write the equation. It is in the solid state, so it melt first, ml, and utilize the energy to reach the 5 degrees Celsius. So I will write here m c delta T equal to about water it is m c delta T. Here the temperature changes from 0 to 5 degrees Celsius, and here is 50 to 5 degrees Celsius. I will write here m is common, m I will take common out, L plus C delta T equal to m C delta T. M unknown, so m as it is I will take. L value is 3 lakhs 36,000 plus C value is 4,200. The change of temperature is 0 to 5, so I will just write 5 equal to the mass of hot water 170 grams. You must take into the kgs, so 170 grams equal to 0.17 kg into 4200. The change of temperature is 50 minus 5, then m equal to 3 lakhs 36,000 plus 4200 into 5, close the bracket, write 0.17 into 4200 into 45. Now first multiply and add the left hand side, m equal to multiplied, what you will get 4200 into 5 plus 3 lakhs 36,000, it is equal to 3 lakhs 57,000 equal to multiplied again 0.17 into 4200 into 45, it is equal to 32,130, is equal to 32,138. then M equal to 32,130 divided by 3,57,000. Divided, you will get the answer 32,130 divided by 3,57,000 is equal to 0.09. So it is equal to 0.09 kg. Then how many grams it is? 90 grams. So in the left hand side we have taken the equation for the ice gaining the heat energy. The right hand side I have written the water at 50 degrees Celsius losing the heat energy. Our final answer is 90 gram. We will go with the next one. Find the result of mixing of 10 gram of ice at minus 10 degrees Celsius with 10 gram of water at 10 degrees Celsius. A specific heat capacity of ice 2.1 joule by gram Kelvin. A specific latent heat of ice 336 joule by gram, and specific heat capacity of water 4.2 joule by gram Kelvin. So ice we have 10 gram of ice at minus 10 degrees Celsius. Okay, in this one we are going to find how much mass of ice is melted. Then I will write the equation here for this. The first one is its mass considered as capital M. This mass considered as small m. Here we need to find the result. I mean, we have here unknown mass m dash. How much ice is melted? We will see it. Then we energy gained by ice at minus 10 degrees Celsius to come ice at 0 degrees Celsius. So I will write the equation here. M C delta T plus, we don't know how much mass is melted, so I have taken M1 and L equal to about hot water at 10 degrees Celsius coming to freezing point. So I will write here M C delta T. The ice mass is 10 grams. 10. A specific heat of ice is 2.1. Change of temperature is 10 plus m dash. A latent heat 336 equal to mass of water 10. A specific heat of water 4.2. Change of temperature 10 it. What will you get? This is 210 plus m1 into 336 equal to 4000, sorry, 420 it is. 420. M1 into 336 equal to 4000, sorry, 420 minus 210. What will you get here? 210 you will get it. Then it is M1 to 336. M1 equal to 210 by 336. Now divide it to get your final answer. 210 divided by 336. You will get 0.625. 625 gram. So how much ice is melted here? 0.625. grams of ice is melted. The remaining quantity of ice in the solid state. Okay, now we will go with the next one. A piece of ice of mass 40 gram is added to 200 gram of water at 50 degrees Celsius. Calculate the final temperature of water when all the ice has melted. A specific heat capacity of water is 4200 joule by kg Kelvin, and a specific latent heat of fusion of ice 336 into 10 power 3 joule by kg. First, this is also method of mixture. Energy, heat energy utilized by the ice to come to the certain temperature. Let us take the certain temperature is a T. The water at 200 grams at 50 degrees Celsius. So I will write here. First, the complete ice is melt. Then ml plus this water, this ice melted into water. This water rises to a certain temperature, that is a T temperature from zeros. We will write it here. M T delta T equal to M C delta T. Again here, we don't know what is the final temperature here. This is the mass 200 is a M, 40 gram is a capital M. Remaining, as you know well, 40. I will convert into kgs. 0.04 latent heat 336 into 1000 plus 0.04 into water na 4200 into the change of temperature, it is from T minus 0. The final temperature is a T minus 0 equal to mass of water is 200, I mean 0.2 into specific heat of water 4200 into the change of temperature is 50 minus T. Just calculation part here, we will calculate it. First we have to multiply 0.04 into 3,36,000. What will you get? 13,000. 13,440 plus 0.04 into 4,200, 168 you will get. 168 T equal to 0.2 into 4,200, it is 840. 840 of 50 minus T. 13,440 plus 168 T equal to 840 into 50 minus 840 into T8. Then we will see what the step we will get now. First I will multiply 840 into 50. We will get 42,000. 42,000. So before I will write here 168 T plus 840 T equal to 42,000 minus 13,440. Subtract and add. What will you get? 168 plus 840 equal to 1008. 10080 equal to, subtract 42,000 minus 13,440 will get 28,000 28,560. Okay, for the next step we will write T equal to 28,560 divided by 1,008. Then T equal to, once again divide 28,560 divided by 1,008. Will get 28.33 degrees Celsius. 28.33 degrees Celsius. So this is the ninth one. So for up to now we have seen only one formula. Method of mixture, net gain equal net loss. Here assumption is nothing but the energy is conserved. There is no loss of energy. 10th one. Calculate the mass of ice needed to cool 150 gram of water contained in a calorimeter of mass 50 gram at 32 degrees Celsius, such that the final temperature is 5 degrees Celsius. A specific heat capacity of calorimeter 0.4 joule by gram Kelvin. A specific heat capacity of water 4.2 joule by gram degree Celsius. A latent heat capacity of ice 330 joule by gram. So here in this one we have to find the mass of ice. Given 150 gram of water, this is the water, 50 gram is calorimeter, water and calorimeter at 32 degrees Celsius, and the final temperature at 5 degrees Celsius. This is for calorimeter and this is for water, latent heat it is. So let us take here the method of mixture. We will write the equation here. So first, let us consider it is ice is said that the ice in the solid state first it melt. So I will write here ml, ice melted. Then it reaches to 0 to 5 degrees Celsius. So I will write here mc delta T equal to the mass of water, a specific heat of water, the change of temperature of water, plus mass of calorimeter, plus a specific heat of calorimeter. So I will write Cc, and then the change of temperature delta T. Mass mm is common from the both. I mean, in the two terms, I will write here the m of L value is 330 plus C is, it is for water 4.2, change of temperature is 5 equal to mass of water 150, specific heat 4.2, Change of temperature 32 to 5 into 27 degrees Celsius plus mass of water, sorry, calorimeter 50, specific heat 0.4 into change of temperature 27 degrees Celsius. Okay, let me multiply and add in the left hand side. 4.2 into 5 equal to 21 plus 330, 351 it is. So m of 351 equal to 150 into 4.2 into 27, 150 into 4.2 into 27, you will get 17,010 plus 50 into 0.4 into 27, 540. Add the both here, 17010 plus 540 equal to 17,550. It is equal to 351 into m. Then m equal to 17550 divided by 351. That equal to divide by 351. You will get 50 grams. 50 grams. So 50 gram of ice is added to 150 gram of water and 50 gram of calorimeter. So here the assumption is there is no loss of heat energy. In this class, we have done five problems from calorimeter.